Hey guys, so in this video I'm going to show you how to apply the second index law out of the 4. Okay, so the second index law is a to the power of m divided by a to the power of n will equal a to the power of m minus m. Alright, so it is pretty much the exact opposite of our first law. Okay, so if we are timesing them together, we will plus the powers. In the second law states, if we divide them, we minus the powers. Okay, now if there are coefficients are present in the second law, okay, the coefficients are divided together normally, and then the second law is applied. So very similar to the first law with multiplication, but with division. Okay, now the one thing extra that the second law has is if the coefficients do not divide evenly, then all we do is we simplify the fraction down and then apply the second law of up here. Okay, so let's do some examples. The first example, we'll just do something basic, which we'll do 5 to the power of 10 divided by 5 to the power of 3. Okay, now we can see straight away that these are both the same base value. Okay, so we know we can apply the second law, and what we would do is 5 to the power of 10 minus n, which would be 3. So this would be 5 to the power of 7. Alright, we'll look at example number 2. So in example number 2 we'll do something very similar to this, but obviously you might see things with questions with variables rather than numbers. So you might say something like this: d to the power of 12 divided by d to the power of 4. Now, as you can see here, pretty much exactly to the rule we have at the top here, our base variables are the same, okay, just like our base numbers were the same in this example. All we do is we subtract our powers, just like you see up here. Alright, so it will be d to the power of 12 minus 4, which is m minus n, which would be d to the power of 8. Alright, do something a little bit different for our third example of questions you might experience involving this topic. Alright, so now we're going to use some coefficients. Alright, so we will do 36d to the power of 7 divided by 12d to the power of 3. Alright, now we know that if coefficients are present, the coefficients are divided normally, just like in the first law of multiplication, and then the second law is applied. Okay, so we look at our coefficients, which we know are the numbers in front of our variables. Okay, that's our coefficient. So 36 and 12 of our coefficients. Alright, so this would be 36 over 12, and then also d to the power of 7 over d to the power of 3. Alright, and we work that out. How many times does 12 go into 36? We know that 12 goes into 36 3 times. And then right here we can just apply our second index law. Alright, so we've divided our coefficients like normal. 12 goes into 36 3 times, and then we apply our second law right here, which we know would be d to the power of 7 minus 3. Okay, so that can be then written as 3d to the power of 4. Alright, now we're going to do something a little bit more complicated now for our final example, or if you're still catching on. So example 4. Our fourth example, we will do 7t to the power of 3 times 4t to the power of 8 all over 12t to the power of 4. So this is going to be something a little bit different. Now first off, we can see that we actually have a multiplication symbol here, not a division, as well as a division symbol, sorry. Okay, so what we need to do here first is apply the first index law, and then we can apply the second index law. Okay, so if you remember how to apply the first index law, still using coefficients, we have to multiply our coefficients together first. Okay, and we know that our coefficients are the numbers in front of our variables, so that is 7 and 4. So this would be written as 7 times 4, as well as still applying our first law, t to the power of 3 times t to the power of 8. And that whole thing is still over 12t to the power of 4. Okay, so we're still breaking down our top part using our first index law. Okay, and that can be worked out back down to 28 is the value of our coefficients right there, plus 28t to the power of 3 plus 8, okay, over 12t to the power of 4. Okay, and that is then 28t11 over 12t4. So what we've done here is we've used our first index law to take this number here, or these numbers here, break them down into 12t to the power of 11. Okay, now what we have is just division, so we can apply the second index law. Okay, now if we go back up here, it says if coefficients do not divide evenly, just simplify the fraction. Okay, so if we go back, does 12 go into 28 evenly? No, it doesn't. Okay, so we can't divide those two evenly. Okay, so what we have to do is we have to just simply simplify it. Okay, but we still use our second law to do that. We still divide our coefficients first, then apply our second law for our variables, and then put them together, but in a simplified form. Okay, so it's still 28 over 12 times t to the power of 11 over t to the power of 4, which can be broken down into 28 over 12 times t to the power of 11 minus 4, okay, which is 7. Alright, now because 12 can't go into 28 evenly to get the exact number for this, okay, then we'll just simplify this fraction. And the way we simplify fractions are by finding the largest number that fits into both of these numbers evenly. Okay, so that would be 4. So how many times does 4 go into 28 evenly? 7. How many times does 4 go into 12 evenly? 3. Times by t to the power of 7, and that whole thing can be written as 7t to the power of 7 all over 3.